Okay, so we've typed in sudo apt update to the command line, okay? And then after that, sudo apt upgrade, okay? And so I'm assuming that your screen looks kind of like mine right now. Is that right? Yeah? Okay, so this is going to take a little while, but that's okay because we have other things that we can be doing right now, okay? I have a few slides that I need to show you. Now, I want you to know that this is not a slides class. This is not like ENR 101, okay? It's going to be more like ENR 200 where we're doing stuff with the computer the whole time, okay? But I do have a few slides to show you because I need to talk to you about why you're taking this class and what the point is and how all this kind of fits together in what we're doing in our curriculum here with you, okay? So this is kind of one of those big picture kind of context things. So let me just go in here and open up what I got here. Yeah, okay, let me go to the front. Okay. And I'm gonna go to presentation. There we go. Okay, so you guys can see this now, right? It doesn't have the right date on it, but that's okay. All right, this is, all right, so we're gonna talk to you about, I'm gonna talk to you today about a little bit of history, a little bit of philosophy, kind of why we're doing this big picture type stuff to give you some context, okay? So, has anybody ever heard of this guy, John Napier?
I've heard of him.
He looks familiar. Okay. Does he look like somebody related to you, maybe? Okay, so you can probably guess from his clothes that this is a picture from quite a long time ago, all right? He's wearing what was called a ruff, very stylish, in the 15 and 1600s, okay? Not anymore. Okay, so who was this guy? He was a mathematician. He was a physicist. He was an astronomer who lived in Scotland, okay? And he was born in Edinburgh, in fact. He was also a theologian. Educated people in those times often had very wide interests and worked in lots of different areas, okay? So that's Napier, okay? Now, he knew a lot about theology, wrote a lot about religious topics, but he is most famous for inventing logarithms, which I'm sure you encountered in at least one math class that you've taken in the past, okay? What are logarithms? You may not remember what they are because it depends on whether you use them very much. They are inverse functions of exponentials. So he's the guy that invented these, okay? That's what he's most famously known for. He published an invention in a book in 1614, okay? And you can see the title of it in Latin, Mirifici Logarithmorum Canonis Descriptio, a description of the wonderful canon of logarithms. He called them wonderful, okay? He thought they were just awesome, okay? So he's very enthusiastic about this, right? Okay, but he also invented the idea of a decimal point, which is also very useful. So we're very grateful to him, okay, for what he's done. Those are the math things that he's done he's better known for than anything else. Okay. In 1617, he invented something called Napier's bones. Has anybody ever heard of those? I had never heard of these before. Okay, but you wonder what are Napier's bones? Well, first I'm going to show you a picture of them. Okay, here's an example of Napier's bones. So what these are a whole bunch of rods with numbers and lines on them that are cut into them. Okay, and what are they exactly? They are a calculating device, okay? And they were a set of rods, okay? You saw that they were rods, and they were typically made maybe out of bone or ivory, okay? That's why they're called Napier's bones, okay? And they were inscribed with multiplication tables. Now remember, nobody had calculators then, okay? So thinking about how useful calculators are, how computers can do a lot of computation for us, it really speeds up our work. They didn't have those, okay? So he was clearly somebody who needed to do that kind of thing. He figured he wasn't the only one, and he came up with this idea of this set of rods, okay? So how do they work? They were divided into squares. The digits are arranged in a way to allow users to perform complex calculations. It depended on how they laid the rods out with each other, okay? All right, so these were used for computation before the next thing got invented that was better, easier to use, okay? And that was the slide rule, okay? Now remember, he invented these around 1614, 1617, something like that, right? Okay, so the slide rule came along. This is a slide rule, okay? 300 years later. Okay, so people that did computation, they mostly used Napier's bones. Nowadays, nobody doesn't even know what they are, right? Completely unknown, okay? They were superseded by the slide rule. Have you guys ever seen pictures of slide rules before? These are a little bit more recent, so you might have encountered these, okay? Does anybody know how to use a slide rule? No, right? Nobody knows how to use them. If you watch old movies about nerds, you might see them in slide rules, okay? They're not used anymore, okay, because they've been superseded. So the idea here is that you have, basically, I think they were made out of ivory or wood, probably wood, polished wood, and there was a centerpiece that slid back and forth. You can see how it's here, right? And you can see how it looks like a bunch of rulers that you align, okay? And the idea it was a way to do computation. And then you had this other thing here, this slides along also. The reason I know this is because my father is an electrical engineer and he had a whole bunch of these things, okay? So when I was a child, my sisters and I would take these slide rules, and they were like maybe this long, and we'd take the centerpiece and we would extend it as far as we could with, where it still stayed in it, and then we would do sword fighting with it, okay? We were little kids. I had no idea how to use these things. I just know that he used them, okay? And so they were the thing that engineers used. And in fact, a lot of engineers carried a slide rule around with them at work. They would have it in a pouch that would hang off their belt, okay? Like almost like a sword hanging down. Okay, it was a very common thing. Everybody had one. Okay, so the slide rule was invented by this man named William Oughtred, okay, who was a mathematician and priest. And he actually invented the slide rule in 1622, but then they got used for a while, okay? Actually, I thought that the slide rule came long after Napier's bones. I apologize. I thought it was a much more recent invention, but no, it was invented in the 1600s also. Okay, so engineers used that. Oughtred also was the guy who invented the time symbol and the proportionality symbol, this thing. You may have seen this before in math problems. Okay, that little thing that means when two things are proportional to each other, you put that symbol in between. Okay, then the next thing that came along was the calculator. Okay, so this one is much more familiar, right? The very first calculator that was available to people in general was Hewlett-Packard's HP 35. Okay, so if you look at this ad for it, okay, it says it gives you the portability and convenience of the slide rule. Okay, meaning they're appealing to people who were using slide rules. So they figure it's engineers mostly, right? It gives you the problem-solving power of a small computer, right? And it's priced so you can have this capability in your shirt pocket. Okay, so then slide rules became obsolete, right? And then everybody moved on to calculators. Now, Napier invented Napier's bones. He also came up with logarithms. We still use logarithms. We don't use the bones. Okay? Oughtred, he came up with the time symbol, the proportionality symbol. He came up with the slide rule. We still use the time symbol, the proportionality symbol. We don't use the slide rule anymore. Okay? So you have concept and you have technology. Okay? They're two different things, right? You can work on both, but one thing is going to endure more than the other. Okay, so this is the HP 35. Okay, it was released in 1972. Okay, it was the first scientific calculator that was handheld. Okay, before that, if anybody wanted to use computation with a computer, it was extremely involved to do it. It wasn't something you carried around with you in your pocket. Okay, so at the time, it was priced at $395, which would be equivalent to $2,500. Now, my father bought an early HP calculator. It wasn't that early. He got one in the mid-'70s. It was $125, which was quite a bit of money at the time. He carried it around in a special leather case. Okay, so think about how we deal with calculators now. We're very casual, right? I mean, I have a calculator. I paid, I think, maybe $8 for this at Walmart. You know, I just like having a calculator. This is me just because I like them. I don't have a calculator app on my phone though, right? Because that's what most people do now if they want to have a calculator. Okay. All right. So by the end of the 70s, nobody used slide rules anymore. Okay. So I was in college in the 1980s, and occasionally in my physics class, they would show us videos of different things. And at one point, there were these old black and white things, you know. They showed us have you guys seen the Tacoma Narrows Bridge, the one that goes like this and then it collapses? Right? They show us movies like that, but there was one where they showed a couple of guys talking about physics concepts, and one of them whips out a slide rule and starts using it, and the whole auditorium just breaks out into laughter because slide rules were just so passé at that point. Nobody used them anymore. It was very clearly a dated thing, and not that much time had passed since people stopped using them, but none of us used them. Okay, so HP became very successful, very rich from having these calculators, right? And then Casio and Texas Instruments went on with there too. So if you have a calculator now, it might be a TI calculator if you have one, okay? But a lot of people don't have them anymore. Okay, so that's calculators, right? They've been superseded now by apps on your phone. Now let's talk about drafting. Okay, so this picture here, this is a picture probably from, I would say, the 1960s. And this is in Bismarck, North Dakota, at the North Dakota Department of Transportation. So what you see here are a bunch of probably civil engineers doing drafting, okay? They're not using CAD, are they? Okay? What are they doing? They've got big drafting tables. They've got protractors. They've got rulers. They've got T-squares. And they are working with big pieces of paper, and they are drawing by hand, okay? Now, they're drawing by hand, okay, on a big piece of paper, and then immediately under the piece of paper is a piece of carbon paper. Do you guys know about carbon paper? Okay, carbon paper, if you take a piece of carbon paper and you put it like the contents of a sandwich in the middle between two layers of bread, meaning two pieces of paper, if you write on the top layer of paper, then what you're writing will be traced out on the bottom layer of paper, okay? Probably in the color blue, because that's what the carbon is set up to be. The carbon paper is blue, okay? And so you draw on the top layer, and then when you're all done, you pull it away, you take the carbon paper off, and then you're left with a big piece of paper where your drawing has been duplicated in blue. And that's where the name blueprint comes from. Okay, that's where it comes from. Just from that process of doing this. Okay, so these people who did this work, they had to be meticulous. It was detailed work. It was difficult to do. If they made a mistake and they couldn't really correct it easily, they had to take the piece of paper and like smush it up and throw it out. Okay, and then they're stuck redoing the whole drawing. All right, so it was very time consuming. However, a lot of them were really good at what they did, okay? It was very good for their minds to have to do this, but it took a lot of time, okay? That was the problem. So, prior to 1960, that's how technical drawings were created, okay? And then these were the tools, all right? They had those big tables, like in the picture, right? And then you had to be precise, and it took a lot of time, okay? And then sometimes you had to start over, like I just said, okay? And this was how things were reproduced. There were no photocopiers. Nobody had any photocopiers then. Okay? And then CAD was invented. Okay? CAD was invented, and this is a very early version of CAD. You see this guy doing his drawing on that screen. Okay? People were overjoyed because engineers get paid a lot of money, and if they're spending a long time making drawings, it gets expensive. Okay? For companies or the DOT or whoever it was that needs these done. Okay, so when did CAD start getting used? In the 1960s. Initially on what are known as mainframe computers. Okay, computers were very large. They would be used by multiple people. When we talk about these mainframe computers, they were less powerful than the computer that's sitting in front of you right now. Okay. The system that everything is based on is the Sketchpad system that was created in 1963. Okay. And then there were CAD software in the 1970s was developed more, okay? And basically the original CAD software was developed by graduate students at MIT. And then because people will often just make software and put it out there for anybody to use, you may have noticed that if you've poked around on the internet, you find that people are eager to share their software. Hey, I made this cool thing. Here you go. Well, Autodesk took that free stuff and repackaged it and started selling it to people. Okay, so they made a lot of money off something that was initially free. Okay, in fact, Creo, which is one of the big CAD companies now, or the CAD packages you can get, if you want to get a license, it costs $35,000 annually to get a Creo license. Okay, so it's become very lucrative for some companies to do this. Okay, so some of these other ones, you may have heard of them if you're familiar with CAD. Okay, but these other kinds of CAD are available. Okay, and then there's other stuff that's more recent. So CAD continues to be developed and made more sophisticated. All right, now CAD. What's happening with CAD? CAD is changing more. Why? Because of ChatGPT. Okay, which I know you all know about. Right? So the fact that we have OpenAI, ChatGPT, has changed a lot of things. Okay, a lot of things. I'm sure you've all used it. Okay, and then workflows are changing in business. Okay, the idea is that in business you're trying to get stuff done as quickly as possible. That's why when CAD was developed, it was something that companies were happy about because they said, hooray, it'll be faster to develop drawings, it will be less expensive to develop drawings. When people are in the workplace, they want to get their work done quickly, okay? So the mentality of an engineer in the workplace is, what matters? Get it done fast, and the answer matters. Okay? This is in the workplace. Okay? When you are an engineering student, these things are not true. Okay? To prepare you for the workplace, we don't get it done fast. Okay? We don't do that. We say concepts matter. Okay? Understanding matters. Okay? Thinking matters. Okay? Process matters. The process matters. Why? Why do all these things matter? Because we're trying to form you. It's formational. It forms your thinking. You can't function as an engineer or a computer scientist in the workplace unless you have this formation. Okay? So sometimes we'll have people say to us, not necessarily students, sometimes it will be people who are interested maybe in hiring our students. Well, do your students know, do they know AutoCAD? They have to know AutoCAD. You say, no, they have to understand how CAD works in general and the concepts behind it. We want them to understand the process. The specifics to a particular type of CAD, there are so many out there. If we teach one, they're not going to know the other one. And it doesn't matter. We want them to understand how to learn. Okay, so if you've had some exposure to CAD, you get what it's about and how it works. Somebody can just give you the documentation for AutoCAD and you can learn it, because really it's just a matter of like, where are the buttons? What are the specific things that AutoCAD is good at, okay? So we're not a training program, okay? Training program just trains you to use a certain kind of software. We want to educate you so you can learn how to use new kinds of software that you're going to encounter, because you're going to keep encountering it, because technology is changing and changing and changing, and the rate it's changing at is speeding up quite a bit, okay? So these changes that have come, like we go from Napier's bones to the slide rule lasts 300 years, and then onto the calculator, and then the calculator is now basically obsolete, okay, right? People like me still like to use them, but, you know. So it's going to keep going faster and faster, and AI being in the mix now is going to change things as well. Okay, so AI will reduce or eliminate the need to learn the details of specific CAD software, because you're going to be able to tell the CAD what to do. You're going to be able to say, make this thing for me, and then give certain specifications, and then it will be produced. Okay, so you're not going to need to know anymore how to do that, okay? AI-driven design assistance. So it will optimize the models based on constraints. But the thing is that you got to understand is if you don't know how CAD works, you're not going to be able to use this effectively. And you're not going to know if what it produces is actually correct or reasonable. Because the thing with AI is, you've probably seen some of the screw-ups that AI does. Like, you know, when it makes pictures and people have like 7 fingers and things like that. Have you seen that? Right? Okay, you got to look at it and you say, I know people don't have 7 fingers. How do you know that? Because you have that experience. You have that knowledge, right? You need to have knowledge of the technology that you're using. It's speeding up your work, okay? It will speed up your work here, okay? And maybe somewhat now, but we're more interested in this, okay? This thinking stuff, okay? So the analogy that I use with AI is to a calculator, okay? If you are 5 years old and you go into kindergarten and it's time to start learning about arithmetic, okay? Nobody is going to give you a calculator right then and there and say, okay, this is how you're going to do arithmetic. Here's a calculator, right? You have to learn how addition works, what it means, what subtraction is, multiplication, division, fractions, all these things. And then later, when you understand these things, the calculator will speed up your work, right? Because you already understand, right? But the thing you got to keep in mind is when you're using tools, okay, like if you're using a calculator, because I'll use that just as an example, okay? Calculator, okay? You've got to have an idea of what to expect as an answer or else you're not going to use the calculator effectively. When I was in college, we could bring calculators into physics exams. I was in this physics class that had 300 people in it. We had to take exams at night, and they would give us these multiple choice tests, and there would be 10 answers, like A through J for every single thing. It was a nightmare. I'm still getting over it. But the thing that they would often do was this. They would put on an answer like this. They would give you a problem to do, and then they'd say, okay, answer A, the answer is 10.3. Answer B, the answer is 1.03. Answer C, the answer is 0.103, and on like that. Like, why did they do that? Because people would often screw up entering the numbers into the calculator, okay? Because they're flustered, you know, they're doing the thing, they hit the wrong button or whatever. But if you don't have any idea of approximately what the answer should be, you're not going to realize you made a mistake, right? You need to have knowledge of the thing that you're using. So you don't want it to be that the calculator, that you kind of delegate thinking to the technology that you're using to assist you. It's a tool to help you, but it doesn't replace your mind, okay? That's the thinking here, okay? So I'm just letting you know this. You got to think about these things like this. So even with the AI, right? Sure, I mean, if you want to use CAD to design a structure like a house later on, fine, but you better make sure that the load-bearing walls can actually bear the load, okay? And how is the AI going to know that? Not necessarily, okay? But it's on you to figure that out. So things like that just to keep in mind, okay? All right, so it's going to be nice to have these problems handled, okay? That you'll be able to provide high-level specs. It will speed up your work. Software will handle details, okay? And you're going to be able to give constraints, okay? And that's all fine. It will speed up your work, okay? But that does not replace you as an engineer, okay? There's all these different things you're going to be able to do, right? So there are features that go along with this that will be very nice to use, and it's going to become more and more common. When you graduate, you're probably going to be dealing with this kind of stuff, okay? So think about what's happened, right? Like I said, slide rules became obsolete by the 1980s, and then drafting after that, okay? Nobody was doing hand drafting anymore. It's all CAD, right? Calculators have become obsolete, basically, all right? And then by 2030, probably CAD software will be obsolete. Will we still teach it to you? And well, you won't be here anymore, but you know, in ENR 200, maybe we will. We might, because it's not, the point is not to learn how to use the software specifically. It's what goes into doing a design, okay? That's the part that matters. Okay, so, but all these tools, which keep changing, and it gets faster and faster and faster, they all rely on the same fundamental concepts, and that's the stuff that we want you to know. We will use technology as a vehicle for conveying these concepts, but the concepts are the thing that matter, all right? The fundamentals have not changed. We still have logarithms, for example. Okay? So, the fundamental principles of engineering remain the same, and it's important for you to be proficient in mathematics and problem solving. Problem solving is something that we absolutely emphasize in our curriculum, and we want you to have the confidence that you can use new tools as they come along, because they are going to come along. Okay? So you have to learn how to think and learn how to learn. Okay? So the mathematics behind all right, so CAD, what is it? It's finite element analysis. The software interface is incidental. So as I was saying, we want you to be able to use the new tools as technology evolves and even maybe come up with your own tools. This class will help you become proficient in the ability to make your own tools. Okay? And then the other thing is, like when you talk to employers, they might tell you that something is industry standard. And that's true maybe right now. Okay? But that's not going to be the case in the long run. You want to be able to move on and be flexible and adapt to technological change. Okay? So what's going to happen? AI is going to handle repetitive tasks and it will help speed up your work. What will engineers focus on? Problem solving. Okay? Design. Decision making. Okay? And then ethical considerations, right? You have to decide, is this a reasonable thing to do? Would it be morally, ethically correct to do this thing that we're suggesting? Okay? But the fundamentals are the key. So that's why we make you take math classes. That's why we take you take chemistry. That's why we make you take physics. That's why you take foundational engineering classes. Okay? All right. Tools change, principles endure. That is the conclusion. I think I have one more slide. There we go. Yep. Okay. So that's the idea here. Do you guys have any questions on this? So this is like a pep talk, okay? I'm trying to frame this for you. What you're going to learn in this class are techniques that will help you to gain confidence in using computing in general, Linux in particular, okay, and how to speed up your work, okay? You're going to learn about how to do that even with the tools that you learn here, all right? Let's see if I have anything else. Is that it? Okay, problem solving, critical thinking, and decision making. Yes, so that's what we have here for you, and these are important parts about our curriculum, and this class is going to move you forward for that. Okay? Anybody have any questions about anything? No? All right. Okie doke. Let me get out of this then. And let's go back. Now, I'm hoping that everybody's stuff has finished by now. That was part of the reason I did that. Okay? Yes? Does everybody have their prompt back? Okay. Okay. So, I wanted, Dylan, can you hand out these papers now? I have here, this is the little summary of basic Linux commands that I handed this out in ENR 200, and so if you took it with me, I know you got this, but I'm giving you another copy of it, and if you didn't take it with me, you may have gotten this, but this is just a summary of some basic commands for using the Linux operating system that, well, if you don't know these, then you can use this as a reference, okay? One of the things I want to now do is look at a particular, I'll call it an app, because that seems to be the term that's most familiar to people, okay? When you think of an app is a program that does something, right? Okay, so you can check to see if this program, really it's an executable, is actually here on your computer. So let's type which eSpeak. Okay. Okay. I just got my prompt back. Did you get your prompt back? Hopefully you did. Pretty much everybody did, right? Okay. When you type in which and then some name of a program or something, and then you just get the cursor again, what that tells you is that program is not installed on your computer. Okay, so let's install it now. All right, so this is how we do it. Sudo apt install eSpeak. Okay, sudo apt install eSpeak. Okay, now I have to put my password in. And as Dylan said, it's not going to show up. You just type it in. Okay, now it's telling me, hey, you know, you're going to have to set aside some space for this. Are you okay with that? And I'm thinking, sure. Okay, so that didn't take too long to install. Hopefully it didn't for you either. You got it? Has everybody got it? Okay, now let's type in which eSpeak again. Okay, so now you should see user bin eSpeak. Okay? Yes? Does everybody see that? Okay, so the executable for that, the thing that you can use to run, basically, to make eSpeak work is there, okay? And it's a binary file, so it's in that particular directory. So we just leave it there. We know where it is. That's fine. Okay, we know it's there. Okay, now let's type some other stuff. Let's type echo, and then use a double quote, hello world. So those of you that have done programming before, you know that hello world is kind of like the first thing that you do in programming to get something started. Okay, when you use echo, all it does is it puts on the screen the thing that you just asked it to say. It's an echo, okay? Now, what we can do next is the following. I'm going to get the command back by using my up arrow key, okay? And then I'm going to use something called a pipe. Okay, a pipe is the vertical bar. If you look at the enter key on the east side of your keyboard, okay, just above the enter key, you'll see a key that has a slash on it and a vertical bar. You want to put the vertical bar in, okay? And then that's called a pipe, okay? And then you want to type in eSpeak. Okay, and then go enter. Yep. Okay, so it's a little speech synthesizer. Okay, it's kind of cute, right? So what happened? Hello World was fed to eSpeak. The way the pipe works is it takes the output of this first thing that you typed and it passes it along to the thing that comes after the pipe. Okay? I haven't tried to use it like this. If I do it like this, will it work?
Hello world. Hello world.
Okay. I don't know if mine worked.
Hello.
Is it because you're muted?
Maybe I'm muted, yeah.
That's what's thinking hello.
Yep, I'm muted. That's exactly what it is. I'm muted. Okay. Okay, here we go. Okay, yep. You very cute. All right, somebody who's going above and beyond. That's awesome. Okay, so. All right, so now you know how to use it. Awesome. Okay, great. We've made progress already. Okay, so that's the way a pipe works, okay? So you're going to be learning how to do a whole bunch of things using Bash. All right, Bash is the language that we use to interact with the computer through this terminal window, okay? And so the idea here is that we're going to be putting a whole bunch of things together and using them here. Let me see if I can find something I'm supposed to do here. Okay. Yep, you can make it do all kinds of things. Okay. One other thing that I want to talk to you about is the downloads directory. I know that I did this with my classes, but some of you didn't have me in class. Did you guys set your downloads directory to be the desktop? Did you do that already? Did everybody? Is there anybody that did not do that? Because we can do that now. Okay, like if you go over to the menu on the side and you go to Internet. Yeah, some people are having fun here. Okay, that's good. Okay, and you go to Chromium web browser. Okay, you can open it up there, Internet, and you go up to the three dots up here on the side. You can select settings. Okay, and what you want to do is choose the downloads over here on the menu on the left. You'd like to set it to Home Student Desktop, okay? Home. Try typing in a nonsense string and see what happens. Have you done that already? Like something that's just a bunch of letters. So it's Home Student Desktop. It's capital D desktop, okay? But you want to set it to that, and that way, if you Very cute. When you download something, you'll know where it goes. It goes directly to your desktop, okay? Okay.
Do you want it in the desktop and then download, or just
Yes,
desktop?
I have desktop download.
Yeah. I have a file for like the download.
You have a file called downloads on your
Yeah.
desktop? I mean, if you want to do that, you can. I just put it directly on the desktop myself. It's up to you. Just so you need to know where it's going, and having it go to your desktop is the best thing, okay? Is everybody done that? Have you all been able to set your, is there anybody that has not? No? Okay, so you guys have done that, okay. All right. Okay, let's do a couple more things now. These are things I'm not sure if the preferences have been set already on your computer. But let's go in and open up, what do you want to do? Okay, click on the background, okay, of your computer where it says desktop preferences. Okay, see that, desktop preferences? Okay, so I clicked right to get that menu. I just put my mouse directly on the background, and then I clicked right to get this menu. I'm going to click left on desktop preferences. Okay, so you should get a window that looks like this. I'm going to shrink this down now here, like that. Okay. All right, now in here, I am going to go to Advanced. You should have all of these shortcuts unchecked. Okay? That good? Everybody got that? Okay. All right. So we don't want shortcuts on the desktop. We're going to be putting files that we're using there, and we'll delete them at the, by the end of class, except for the ones that we want to keep, and then we'll file them in the appropriate places. Okay, so that's that, desktop preferences. All right, now the file manager. If you look down here, okay, in your toolbar at the bottom, you'll see something that looks like a little filing cabinet drawer. Okay, you want to click on that. All right, now this is probably the thing that you're most accustomed to looking at from, say, a Windows computer or a Mac or something like that, where you have this thing set up where there's a whole bunch of little folders, right? Okay. We are not going to be using this very much at all. Okay? We're going to be mostly navigating from the command line. But let's go in here and see if we want to get this. We want to go to Edit and then Preferences here in this window. Okay, and here, what you want to do is erase files on removable media instead of trash can creation. Okay, do you see how that one is the only one that's checked? So please do that. Okay, what we're doing here is we're getting rid of your trash can. Okay, now don't be nervous. It'll be fine. Trash cans end up taking up a lot of space on computers. People put stuff in there and they go, oops, I need it back. No, no, no. You have to be a little bit more confident and sure about what you're deleting and not deleting, okay? But we're going to not have a trash can on your computer, all right? If you need to what you should be doing is backing up important stuff regularly in the cloud, all right? But we're just not going to be using that. So then if we go to Display here, okay, what you want to do is click these guys. There's only two. Always show real file names and show icons of hidden files shadowed. Those two can be clicked and everything else unclicked, okay? Okay, you guys ready to go on? Okay, a little bit more? Do a little bit more. All right. Okay. Next thing, let's go down to the Ubuntu menu down here in the lower left-hand corner. Okay, what we're going to do here is go into Preferences, and we're going to select Open Configuration Menu. Let's see if I do this correctly. Manager. I think that's the right one. Yeah, this is the right one. Okay, open configuration manager. Choose mouse on the side here, okay? Now I already have mine set up this way, but you want that first box to be checked and nothing else. It says focus windows when the mouse pointer moves over them. What does that mean? Well, if I go and I open up again my my terminal window, let me just put it over here. Okay, what happens? Here's my mouse, right? I've got the mouse and it's on this open box configuration manager. When I slide the mouse over here to my terminal window, what happens? The cursor becomes solid, right? I can start typing in that window right away. I don't have to click on the window. Okay? So whatever my mouse is hovering over, I can type in that window. That's what I've just set up with this configuration by checking this box, okay? It's just an ease of use thing, right? You don't have to do it, but you know, it does make things easier. It's just sliding things around. Especially if you have multiple windows going, it's kind of nice to be able to do that. Let me see what else can we do here. Other things, if you can change the theme if you wish, this is totally up to you. I don't plan on changing my theme, but if you scroll down here, and theme is the top item in this open configuration manager, you see that there are different ways that you can lay out different colors, okay, different styles that you can use. If you want to change to something else from the default, you can surely do that, okay? They're all these different ones, okay? That's totally up to you, okay? Yeah. All right. Okay. Does anybody have any questions on anything we've done so far? We haven't done very much technical stuff yet, okay? This is about as far as the other classes got, though. I would love to do more, but I'm supposed to stay in line with everybody else, so that's all the material that I have for you for today. So I guess I don't have an explicit assignment for you to do this time, so we'll just meet again on Tuesday at 12:30, all right? Please make sure that you bring your computer with you. Okay? That's it. See you guys next time. You're welcome. Okay, I gotta just stop Kazam now. Hang on a second.